Hello, my name is Arturo. I'm a data management specialist here at Google. I've been here for 4 years now. Just a quick intro about myself. I've been doing databases for a really long time now. If you can imagine, I started somewhere as a database administrator for Oracle in a version 7, 1998, so it's a really long time now. Today I'm going to talk to you about Google database offerings, and I'm going to cover more on the transactional side of things, not that much on the analytical side. That's BigQuery. I'm not going to touch that one. And that is because here at Google we like to differentiate our specialties. We have data analytics people. I'm on the data management side of things. So I build pipelines. I help my customers build their architectures and select which databases suit their needs. And that's why the theme of my presentation today is which databases best fits my application. That's what I'm going to try to answer for you today. When I think about the portfolio of databases that we have, and when I get to talk with our customers, for me it's somehow a daunting conversation if we get to talk about all the different databases that we have, because there are many. And each one of those have a lot of different levers and things to move and parameters and constraints, and it's pretty complicated. But what I'm going to be focusing today is to go over an overview of the different databases that we have on this transactional space, try to provide you with an understanding of a general understanding of which we have, and maybe help you out to start to identify which of these are the more suitable for your particular workloads. So let's get going. When GCP was launched, Google started to think about what's going to be our point of view in terms of databases, what our databases must comply with, what are the best offers that we could generate. And that's when these 6 different tenets came to place. So all our databases are being focused on complying with this. The idea is to provide databases that are going to be always on for you. We will take care of backups and high availability scenarios in a way that you don't have to worry about setting up all the infrastructure required to make them always on. It's a really complicated task when you're a database administrator to set up the infrastructure, let alone the database, just the infrastructure to make it high available. We try to make or to create our databases taking into consideration open source technologies. A lot of our customers already are relying on open source because in a lot of the cases it's much cheaper than going with enterprise databases or the traditional enterprise databases that are over there. But it's not only because of cost or the particular technologies that are offered, or even the price. It's because it's much easier to find talent in the market to support our technologies when we go open source today. So it's another of our tenets that we are covering. We try to create our databases in a way that they are scalable and highly performant. And this is one of our main sale points right now. When GCP was created, the main idea was to offer the same technologies that are used to support Google services in a way that now our customers are ready to escalate on our own technologies. And that's why we created them, taking this into consideration. And of course, we don't only provide databases. As you know, we provide a lot of infrastructure, technologies, networking, security, AI and ML, DevOps, monitoring solutions, et cetera, et cetera. The idea is that our databases are highly integrated with everything else in our ecosystem. So the idea is if I provide you with a database, I will try to make it as integrated with other managed services that we provide, or even to help you develop on those so you can leverage on the same technologies and infrastructure that we provide. Of course, we take into consideration our developer community. That's why it makes a lot of sense to make it open source. So our databases are developer friendly. I will gonna talk about some of the technologies that we provide. As an example, we have a document database that was created just because it's really easy to understand for our developer community, and it's not fixed into it is not supported on top of a fixed data model. It allows you to be more flexible in your endeavors. And of course, we take into consideration the cost. The idea is to provide you with more flexible ways to manage the cost of your databases. Usually, when you work or you have your databases on premises, you have to make a lot of investments in advance. When I used to manage my databases, at the beginning, when I started, I thought, yeah, we're going to pay for the license and the server, and that's done. But as you progress, you learn that it's not only the license that you have to pay for. You have to pay for maintenance of the license year over year. And then you have to renew your servers. And then you have people managing the servers. So when you take a look at the enterprise solution that you bought, that it's really cool, it's hyper expensive in terms of how much you have to keep paying to the provider, right? So what we're trying to do is to provide databases that are being priced by how much you use them. And when we think about it, it's a completely switch on the paradigm of how you pay for the services that you use. When you go in the traditional way, you have to invest in advance and keep paying in order to keep using the database, regardless of the database being used 100% of the time. In traditional organizations or in traditional transactional models, you will get the database to really work on office hours, not 24/7 all the year. So it's important to take that into consideration. So what you're seeing here, it's the brief of the most important databases that we are providing right now. This is our main portfolio. And what you're seeing is that we try to provide not only traditional relational databases. You will see here that we have in memory, we provide relational, we provide document, and we provide key value. We're trying to provide databases to support any possible use case that you may have. And that's when things start to get complicated. Now, as you can see, on the left side, I made a box over there that says we support managed third-party database engines. The idea is that it's not only databases generated by Google with our own technology and with our own languages. The idea is to support technologies that are already being used by our customers. That's why we like to play well with others. So you will see there those managed third-party databases. On the right side, these three, Cloud Spanner, Firestore, and Cloud Bigtable, those are our own native databases. These were born to support services such as Gmail, YouTube, our own search engine. So these are highly scalable. They support billions of users each day. And now we're making them available for you to use them. Of course, it doesn't mean that you have to be Google to have one of these databases. The idea is that it's the same technology that can help you escalate, and you will feel comfortable with the idea that these databases are not going to let you down when you hit 1 billion users in the future. So that's the main idea. So let's get started. And I'm going to start by talking about the relational space. My first database here is Cloud SQL. Cloud SQL, it's a managed database that supports MySQL, Postgres, and SQL Server. The idea is that as a database administrator, you don't have to set up the infrastructure to support your database. You can, just by a flip of a switch on the console, get a service for MySQL, for Postgres, or for SQL Server in different versions, the most updated ones, of course. But the idea is that you can get your service running in a matter of minutes, and these are databases that scale up. So let's say that in the future you require to move to a larger server, it's really easy to upgrade your database in a way that you can assign more resources or a bigger server to your database with a transition between the two different infrastructures in less than a minute. It's something that it's really cool about this particular service. And of course, as I said, I'm not going to go into all the details about how it manages the storage and high availability and read replicas and synchronization, because that's a whole session for each one of the databases that we're going to mention. So just rest assured that they have it. If you have any particular question, please interrupt me, and I can focus on that. But I'm going to keep trying to explain the different versions that we have and the options, because the idea is just to let you know that we have them. And if you're thinking about a particular use case that could use them, well, now you know they're there, right? So as I mentioned, our databases were designed to be integrated with other services, so that's why we included this example here. Right now, more than 650,000 Kubernetes engine clusters are being connected to Cloud SQL. A small example, a few minutes ago, is one of those customers that decided to use this type of technology to support their workloads. Traditionally, when I think about databases that only scale up, not out, to adding nodes to a cluster, it makes me think that it's not scalable enough for large use cases. But in reality, the flexibility that we provide for the different server models that support these types of solutions are so vast and huge that they are ready to support really large environments right now. The next one, and I'm going to talk a little bit more about this one. This is a new product. It's called AlloyDB. As you saw on the Cloud SQL mention, we support PostgreSQL. And we are finding out that a lot of our customers love Postgres. It turns out that it's not only very popular, but it's a really powerful database that supports a lot of transactional environments right now. So being so huge, the market and the possibilities to implement PostgreSQL and the feasibility to migrate from other databases to PostgreSQL, things like migrating from Oracle to Postgres, is not that difficult, or from SQL Server to Postgres is not that difficult. So that's why it's really popular, and we are doing a lot of investments in PostgreSQL, and that's why we are developing AlloyDB. AlloyDB, it's PostgreSQL. It's 100% PostgreSQL compatible, but the magic behind it is that it supports an infrastructure model that decouples the compute from the storage, and it has a query engine in the middle. So right now what you have is imagine that you have an application running on Postgres. Right now you can migrate directly to this database, but the good point of it is that the infrastructure and the architecture of this database is different from the traditional one that you are using on premises or maybe on another clouds. What it provides, it's a lot of scalability capabilities, but also great performance. It's much, much performant than the traditional PostgreSQL that you know already. And right out of the bat, you don't have to modify anything. It's just changing from what you already have, put it inside AlloyDB, and it's going to be much faster, just like that. An example of it, we have seen that it provides a 4x faster query response time for transactional workloads. And it's just migrating to the engine in a relatively direct scenario in terms of how much computing are you assigning to this database. Let's say that you have I don't know, maybe right now. Let's say that you have a production environment running Postgres that has I don't know, a 16-core server with a bunch of memory, high disk, and everything over there. If you implement a cluster of AlloyDB with more or less the same specs right now and put the database inside of it, it's going to be 4x faster than what you already have without doing any tweaking or performance tuning to your application. So that's a really good thing to know. And of course, the pricing model is really flexible. And another thing that it does is that it's not only decoupling the computing, but it also provides you with the capability to escalate horizontally. It's scaling out, not only up. So imagine this. Now you don't have to worry about configuring the whole cluster of servers that are going to support your database. Right now it's only migrating over there, and with the console you have a graphical interface just to add nodes to your database, or even bigger nodes if you require it. So it's up and out, directly out of the bat. So it's a great technology to start using it. But it doesn't stop over there, because now that we found out that it's so fast, we could always implement not only transactional, but also analytical workloads on top of the same database. So as you saw with most example, again, they do a lot of analytics on top of Postgres. It has proven to be a really good option to execute analytics on top of our relational data model. But now with this engine, you will have up to 100x faster queries when you execute analytic workloads on top of AlloyDB. So this is one of our, for me personally, being in databases, it's one of the best things that I have seen in a couple of years. And I'm pretty sure this is going GA as we speak. It's scheduled to be GA in the second half of 2022. It's already in preview. If some of you are interested in taking a look at it, it's already available. Of course, since it's not GA, it doesn't have SLAs attached to it right now, but it's going to be fixed in a matter of months. So right now, I think it's a really good option to start thinking about it. So moving on, as I mentioned, we like to play well with others. And we have seen that a lot of the enterprise customers that we have, they rely on Oracle databases. So they use Oracle extensively, and they support a lot of databases, applications running on top of Oracle. And if we think a little about all the Oracle environment, you have this language that is called PL SQL, that allows you to create applications on top of your own database. So now the logic has been created inside the database, and that's why it's really difficult to get out of Oracle when you have an application built on top of that technology, right? But we have seen customers that they don't like the idea of keep managing their own infrastructure. So what they require is something that it's managed for them. So we created this service, and what it is like the name implies, we provide you with bare metal servers to run your Oracle workloads. And the bare metal servers are going to be stored in a partner data center that has a high bandwidth connectivity between these two data centers directly to our Google Cloud services, in a way that you can control your Oracle bare metal from your console in GCP. And of course, the data centers that support these technologies or these infrastructures are certified by our own engineers. So they will provide you with high levels of availability and support and everything around them. So you can rely on them. But it gives you a lot of flexibility as to migrate from Oracle. It's not that you're going to get out of Oracle. You can keep working with Oracle. But now these Oracle databases are going to be directly attached to the application services that we provide, or to the AI and ML solutions that we have already available for you. So it's another really good solution for users that are interested in keep running their Oracle databases, but now with GCP. And if you are interested in this, we have another really big session. If you're you can get in touch, then in which we can talk about the differences that we provide compared with our competitors. So we know, yeah, Oracle has their own databases and their own cloud services, but it's interesting how our Oracle bare metal could be even better than the one that is provided by Oracle, but that's something that can be discussed later, right? So moving on, keeping on the relational space, this one is like the jewel of the crown right now. It's Cloud Spanner. This is the database that it's supporting services like Gmail, the search engine, YouTube even. It's supporting billions of customers every day. And right now, we have other customers that are relying on Cloud Spanner to support their operations. As an example, Gus mentioned Macy's. They decided to go with Cloud Spanner because of the high volume rate of transactions that they manage every single day. The big selling point of Cloud Spanner, by the way, Cloud Spanner also supports Postgres, but there are differences with AlloyDB, and I'm going to go into there right now. The big selling point for Cloud Spanner is that this is a database that has been designed to be strong, consistent. And with this, what I mean is when you have a workload that it's spreading in a cluster of servers, usually you have one master that controls everything, that controls the writes to the database, and you can distribute read replicas around, right? So that will help you to support more customers that are just getting data out of the database. But what happens when you have this environment in which you will have to implement a multi-master environment? It's really complicated when you think about it. It sounds easy, but it isn't. In terms of infrastructure, it's really complicated to implement an infrastructure that is multi-master. Cloud Spanner take care of that right out of the box for you. The idea is that you can implement a cluster of Cloud Spanner servers that can scale as this, more or less in the same concept as Alloy. It goes out and up. But the magic with this is that, let's say that you have a workload that is going to run at a global scale in a multi-region. Let's not get out of the US now. It's just having people connecting to your service on the West Coast and on the East Coast at the same time, and you need both of them writing to the same database in different regions. So right now, Cloud Spanner can be implemented just by flipping a couple of switches. You don't have to modify everything in your application, and the database is going to take care of the writes, and it's going to provide with the strong consistency, and it's also ACID compliant. So you will not have to wait a lot to ensure that the transaction is being applied to the database and then synchronized with the different nodes that take care of that. What makes it happen, or what makes it available or possible, is our high bandwidth network and how we support the storage that makes the database work. So it's a combination of storage, a bunch of switches. The servers that support the Cloud Spanner, they manage these atomic clocks on the data centers that allows you to have the synchronization of time depending on where the transaction is going, in a way that it ensures that everything is being replicated on time, and you will have completely assurance that you don't have to wait a lot until everything is being synchronized between all the different servers. So it's another really big technology available. And as I mentioned, it also supports now PostgreSQL. It started with its own version of SQL, so it was somehow challenging for our customers because they now are really interested in using Spanner, but they have to learn a different SQL dialect to start using it. And of course, you have to adapt your applications to run with Spanner. But as we saw, it's not that difficult for us to implement a different dialect on top of the same architecture. And now, this strong consistency and a multi-master environment can be applied with Cloud Spanner. A lot of the questions that I receive so often is that, okay, but you have AlloyDB and Cloud Spanner. What's the difference? It's not the same thing. And it is not, because AlloyDB doesn't provide you with that strong consistency and multi-master configuration, while Spanner does. So it's a matter of understanding what's the particular use case that you're running into. If it's you need to scale out of what you already have with your Postgres implementation, but you don't have this multi-master implementation, AlloyDB is the option. And of course, if you're going to run a lot of analytics on top of that, AlloyDB is the option. But if you have a requirement that requires this distribution and highly synchronization aspect of the database, then PostgreSDB is the option. Of course, both of them have their differences as to how you implement it and start to use them. So it's really important to take a closer look about what you require. But rest assured, we have a database that is going to comply with what you require right now. So moving on, and now out of the relational space, as I mentioned, I grew up running in the relational space, creating relational databases. So the first time someone mentioned to me that there were different data models, it was like a shock, because it was really difficult for me to understand how a different data model can support an application that is not relational. Just as an example, in the past I used to work as as a consultant for IBM. And at that very moment, we were implementing a master data management application. So for that, we were trying to build this 360-degree view of our customer for a bank. And imagine the use case. You have a new customer getting into creating their first account in the bank when they're out of school. So it's a savings account. So they keep moving on, and as they grow up, then they have a checking account. And then they keep moving on, and then they decide to get a credit card. And then they move on, and now they have a mortgage, and now insurance. And for each one of these different accounts that a customer opens up in the bank, they have a separate data system that provides data for the customer. So it's really difficult for a bank to understand a customer as a customer. They see only different bank accounts and bank numbers. And it's really difficult to know that all of these different services and products that are being sold are related to a single customer. And to do that, it was really difficult to implement this master data model because we were trying at the beginning to solve it with a relational database because that's what we knew at the moment. So little by little, we understand that if we are going to implement an MDM model, maybe the best way to do it is not to use a relational database. Maybe a key value store could be the right option because right now we're not fixed with a particular data model and we can keep adding addresses or maybe accounts to a customer with a particular key, the key being the customer. So now everything revolves around that customer and that's how we solve that. So just to provide you with an example of where do you use a key value database, right? But in our case, we decided that we were going to implement an in-memory key value database. What's the usage of a key value in-memory database? Well, as it says, this is designed for workloads that require microseconds latency. When you need to perform really fast search to provide a service to your customers, let's say you have a customer that you support a really large web-based application, and you need to know the status of the session of your customer in microseconds because you don't want the application or your web server to be slow when somebody hits refresh or moves around the database. You need to keep track of the status of your customer visiting your site. So databases such as Memorystore will help you out to provide these low latency response times for your databases. And not only for that, but for your applications. Memorystore supports Redis and Memcached. These two are other open source technologies that are not that difficult to understand right now. They're very popular. So if you are already running with these two, it's really easy to move on to Memorystore with all the benefits of having a managed platform that is going to support the same workload. And of course, again, it's integrated with all of the different services that we provide. And moving on, and now that we are out of the relational space, the other data model that is pretty popular right now is using document databases. So documents, it's let's call it another way of implementing your data models, but they are much flexible than a traditional relational database. I'm not saying which one is better, it's just they're different, but for certain use cases, maybe document is the way to go. When you have a use case that could be moving over time, as I mentioned, like the example of a customer that enters in that open up an account in the bank and then start buying different products that are supported by different systems. So this means the data model that supports the whole customer can be flexible because it's not going to receive the same amount of addresses or the same amount of relationship with other products. Maybe another way to solve it is by using a document database. A document database, it's a data model that is being supported by documents, as it says. Imagine that now you have, for each particular entry in your database, you will have a document, and this document will have a lot of data inside of it that is pertaining to this particular entity inside of the database. So in a relational database, you will have your database, and you will have tables that are related to each other. In a document database, you will have the same database, but inside of it, you will have collections. So a collection is like a table, but inside of a table, instead of having records, you will have documents. And each document, it's flexible. You can put anything inside of it. So if you're somehow familiar with a JSON string, how it works and how it's been built, you can create documents with JSON inside of it, and now you will have, this is how I see it. It's like having a bunch of small databases that support a bigger database. It's more like that. So it's really flexible. And right now, it's one of the big products that we provide. Firestore right now, it's supporting more than 250,000 active developers. It's being such a document database that it's so flexible and so popular. It's playing well with our developer community, and they are using it a lot. So if you have, I don't know, maybe mobile applications or web applications that you need to build right now, or that you are migrating from other databases, and this is the particular use case that you would like to move on, Firestore is another of the products that it provides. One of the particulars of Firestore that I remember out of the bat is that, let's imagine that you have an application that runs on mobile, but your mobile device is not going to be connected 24/7 because you're traveling, but you're using the application. So what happens when you lost connection? You need to keep using the application locally on your mobile device, but you want your mobile device to synchronize with the main database when it gets connection again, right? So it has its particularities. It's not that easy to implement, but with Firestore you have the capability with using the SDK of the Firestore and the libraries that it provides. It has its own capability to do the synchronization or to detect when the connection is established with the server, and it will synchronize automatically. You don't have to implement a button on the application to synchronize when you get connectivity. So it's going to do it automatically. And it detects where are you staying, so it's going to provide you connectivity with the closer node that you have on the network. So when we are thinking about mobile devices that run around not only the country, but around the globe, and we need to provide fast access to our customers and maintain your application working even though the application is not connected to the network, it's another really good option to use. And I think I'm going to the last one, talking again about key value databases. Google created a Cloud Bigtable. And this is another different schema. It's not document, and it's not relational. This is key value. But as the name defines, it allows you to create a really, really big table that is going to have thousands of columns related by a key. So it's really flexible as how much data you can store for a particular key inside the database. It grows exponentially. But it will provide you with fast access to the details of a particular key. So if you think about it, if you are going to support things like personalization or fraud detection, because this is one of the particular use cases that it's been implemented on top of Bigtable. When you have a bunch of transactions assigned to a particular customer, let's say an account number, you can start creating a different column for all the transactions that happens with this particular customer, right? So you can implement a data model or a machine learning model that it's monitoring all the transactions for a particular customer, and then when something happens because you're going to add a new record, right? It's not a record, a new column to this particular record with the latest transaction. And this transaction goes way up of the standard spend of this particular account. The machine learning model doesn't have to browse the whole database to understand all the different records that are attached to a particular use case, or a particular customer. Right now, everything is in a single row. So it's really fast to identify all the transactions for a particular customer, and it's going to provide you with a fast insight when it detects an outlier of a transaction that doesn't seem like it's a legal one or it's a normal one happening for a particular customer. So it's sub-second analytics on top of a really big table, because now we're talking about a denormalized model that is really difficult to implement in a relational one, and that's when a model such as this is really useful, and it will provide you with a lot of benefits as to how to implement this type of services that are going to run in sub-second times with a particular complex scenario that is detecting a fraud in a really flexible amount transactions for a customer, because when I say this, not every customer has the same amount of transactions, so you don't know how big the table is going to get, right? But Bigtable can take care of it for you. So it's easy for your developers to implement this type of things without going with a relational database, because if we try to do it with a relational database, it's going to be really complicated. But Bigtable is going to take care of it for you. All right? Any questions right now or anything?
Actually, two questions. One, maybe a short one. You mentioned the bare metal Oracle servers.
Yes, yes.
Do you have the same offer for any, like just bare metal servers to anything?
This is a really tricky question.
Can you repeat the question for folks?
Yes, the question is, we mentioned Oracle bare metal, right? We provide these bare metal servers to support Oracle databases. And the question is, okay, but can I use bare metal to other things that are not Oracle only? And my response was, this is pretty tricky, because it's not a particular service that is integrated. Let's say you don't use Oracle. Let's say you want to use SQL Server. I'm just imagining things right now. Well, right now, I don't have the controlling pane integrated inside my console in GCP to control other databases than the Oracle bare metal service that we're providing. But we have partners, and these are the partners that support these data centers that in which you can implement your bare metal. So there is a bare metal service that can be implemented with these partners, and it's going to be directly connected to our GCP services. So it's more or less the same thing, but now we have to talk in detail about what is the particular use case. It can be implemented, of course, but in this case we have to involve a third-party partner that is going to take care of managing your infrastructure and provide it with this high bandwidth connectivity to the GCP services that we provide.
I see. Thank you. So, and the next question, you mentioned the several databases here.
Yes.
What's the support Google gives, like moving between these? Like I'm starting with one, and after a while, I understand that a different one gonna be better for me.
Let me repeat, and you tell me if I got it right. The question is, now that we're talking about databases, what are the services that we provide to move databases from whatever they are into our own projects?
Let's say I'm choosing one of your.
You already have one database?
And just moving to a different one within your portfolio.
So it's a migration of existing other engines into our databases. That's the question?
No, I'm already with GCP.
Okay.
Using one of your solutions. I want to migrate to a different solution within GCP. It's like.
So like moving data between databases?
I think the question is, if he were to use Bigtable and want to use Cloud SQL or any other flavor within the GCP ecosystem, what's the support around that?
It's like, so the question could be, explain us which other data pipeline tooling we provide?
So I wanted some
Could be that?
Can you elaborate a little more on support? What do you mean by support?
I mean, is it like any moving from, just to that,
So let's say we have Cloud SQL, and I would like to move data to Cloud Spanner.
Exactly. Do you have like specific tools for that?
Yes.
Or is like for any other migration coming from the outside?
Yeah, which tools that we provide to move data between databases? If either just to interconnect them or to migrate from one engine to another one. That's the main idea, right? Of course. So thank you for asking that, because I was going to talk on the bottom of my diagram. I have two different services explained over here. One is called Database Migration Service. The other one is Data Stream. These two are created to migrate from other databases that are maybe on premises or on a different cloud provider to our own engines. It could be used to migrate, let's say, from your Cloud SQL, PostgreSQL to AlloyDB, things like that. It's going to help you. But it's not the only thing that we have, and I'm going to try to speak a little bit about it in a minute. But Database Migration Service, it's the service that we created to migrate between homogeneous databases. Let's say that you have MySQL or PostgreSQL and you want to migrate to the Cloud SQL offering. So database migration service is going to help you out to create the pipeline that is going to move the data from your existing database into this type of databases. So it's homogeneous. Think about it like that. It's going to help you out to build that pipeline. The other one is data stream. Data stream has been created to implement CDC capabilities. It's change data capture is when you are streaming data from a database that keeps receiving movements or records or transactions, and you need to replicate those same transactions in the new database that you're implementing on Cloud SQL. It's more useful when you have an existing production environment and you have to start your migration, but you cannot shut down. It's not easy just to shut down, have a backup, put it over here, turn it up, it's done. It's not like that. You have to keep working in parallel with two different databases, and you have to keep synchronicity between those of them. So data stream is going to help you out. Right now, it's like sadly, like we like to do things, we have to go little by little. So data stream right now has been designed to take care of migrations of Oracle databases or MySQL databases. It's where it's working right now, but it can be used. But these are not the only tools that we provide. On the data management space in GCP, we created other ETL or pipeline tooling that we have available. One of them is called Dataflow. Dataflow, it's a managed service that allows you to create your own pipelines of code using your own libraries, such as Python, maybe, and to control the dependencies between the different tasks that you are going to execute. It provides you with monitoring, and it provides you with a bunch of connectors to get data from different data sources and to move them to different destinations. It's more like an ETL tool, right? The other one is Data Fusion. Data Fusion was created with having ease in mind. It's an ETL tool that was created on top of Apache Beam. And it will help you, it will provide you with a graphic interface that is really easy to use with drag and drop capabilities. You have a bunch of connectors in different boxes, so you drag one connector and it connects to a database or to a streaming feed of data that is coming from a particular service, or you need to expose a web service that is going to receive messages. So Data Fusion can help you do that, but then you have to process and to apply some transformations to the data. And again, it has different capabilities preset, in a way that you only interconnect the different boxes or tasks in this way. That's how they are called inside Data Fusion. You configure them, and then you have a pipeline already built. So there are different versions of it. We have another tool that is called Airflow. So you will have different tools available, and I wanted to close with just one message. I already mentioned some of the databases that we have. These are the main that we provide from our GCP standpoint, but they are not the only one. We have a marketplace, and over the marketplace, there are a really large set of other databases available. Let's say that you would like to use things like CouchDB or Cockroach or MongoDB, things like that are available on the marketplace. And again, with tools like for ETL tools, I'm forgetting my names right now, but there are a lot of other ETL tools available in the market that you can implement by going through the marketplace, and it doesn't stop right there. So it's a really vast environment and ecosystem, and we are here to help you out. As Mo mentioned, I'm one of those. I don't like to call myself an expert because I don't think it's possible in the database space to be an expert on everything. It's really big. But I do my best, so I'm the type of person that will come to you and help you out define which is the best architecture that you can implement depending on the use case that you have available. So you have it over there, right? Thank you so much. And if you have any other questions, please let me know.